Hello and welcome to Math Tutorial Bilingual 25. Today we will deal with a problem coming out of the differential calculus, namely how to find the equation of a tangent to the curve. In the mathematical background you can see the graph of a function f with its tangent y in a certain point b. The derivative describes the gradient of a curve at any point on the curve. Similarly, it also describes the gradient of a tangent to a curve at any point on the curve. How can we now determine the equation of a tangent to a curve? First, find the derivative using the rules of differentiation. Second, substitute the x-coordinate of the given point into the derivative to calculate the gradient of the tangent. Third, substitute the gradient of the tangent and the coordinates of the given point into an appropriate form of the straight line equation. And last but not least, number 4, make y the subject of the formula. As an example, let's have a look at question number 1. We have given a function g, and our task is to determine the equation of the tangent to the curve at x equals 1. Afterwards, we have to sketch the curve and the tangent. How can we find now the solution? Step number 1, determine the y-coordinate of the point. By introducing g of 1, we will find as a result 16. That means that we have now found the complete point A with the x-coordinate 1 and the y-coordinate 16. Step number 2 is to find the derivative. G prime of x equals 4 times x plus 6. In step number 3, we calculate the gradient of the tangent. M equals g prime of a equals 10. Step number 4, we need to determine the equation of the tangent using the gradient point form of the straight line equation, introducing a as determined in step number 1. Following the lines and doing some equivalence transformations, this will give us the answer y equals 10 times x plus 6. If we now sketch the curve and the tangent, we can see this in the following graph. F and the point A as well as the tangent is shown. As a small exercise and a summary, let's have a look at question number 2. There we have given a function f, and our task is to determine the equation of the tangent to the curve at x equals 1. Afterwards, we should sketch the curve and the tangent. As a little help, you can see the graph of the function f. Now, if you like, you can try to answer question number 2, and I would be glad to hearing from you in your comments what the solution is. I'm sure you can easily find the solution to question number 2 following the 4 steps as described below. So have fun to finding the answer, and goodbye for today.